The electric power industry is the generation, transmission, distribution, and sale of electric power to the general public. The electrical industry started with introduction of electric lighting in 1882. Throughout the 1880s and 1890s, growing economic and safety concerns lead to the regulation of the industry. Once an expensive novelty limited to the most densely populated areas, reliable and economical electric power has become a requirement for normal operation of all elements of developed economies. By the middle of the 20th century, electric power was seen as a natural monopoly, only efficient if a restricted number of organizations participated in the market. In some areas, vertically integrated companies provides all stages from generation to retail, and only governmental supervision regulated the rate of return and cost structure. Since the 1990s, many regions have opened up the generation and distribution of electric power to provide a more competitive electricity market. While such markets can be abusively manipulated with consequent adverse price and reliability impact to consumers, generally competitive production of electrical energy leads to worthwhile improvements in efficiency. However, transmission and distribution are harder problems since returns on investment are not as easy to find. The largest electric power companies in the world that deal with all aspects of production and sales of electric power. History. Although electricity had been known to be produced as a result of the chemical reactions that take place in an electrolytic cell since Alessandro Volta developed the voltaic pile in 1800, its production by this means was, and still is, expensive. In 1831, Michael Faraday devised a machine that generated electricity from rotary motion, but it took almost 50 years from the technology to reach a commercially viable stage. In 1878, in the U.S., Thomas Edison developed and sold a commercially viable replacement for gas lighting and heating using locally generated and distributed direct current electricity. The world's first public electricity supply was provided in late 1881, when the streets of the Surrey town of Godalming in the UK were lit with electric light. This system was powered from a water wheel on the River Wey, which drove a Siemens alternator that supplied a number of arc lamps within the town. This supply scheme also provided electricity to a number of shops and premises to light 34 incandescent Swan light bulbs. Additionally, Robert Hammond, Indiana, December 1881, demonstrated the new electric light in the Sussex town of Brighton in the UK for a trial period. The ensuing success of this installation enabled Hammond to put this venture on both a commercial and legal footing, as a number of shop owners wanted to use the new electric light. Thus the Hammond Electricity Supply Co. was launched. Whilst the Godalming and Holborn Viaduct schemes closed after a few years, the Brighton scheme continued on, and supply was in 1887 made available for 24 hours per day. In early 1882, Edison opened the world's first steam-powered electricity generating station at Holborn Viaduct in London, where he had entered into an agreement with the City Corporation for a period of 3 months to provide street lighting. In time he had supplied a number of local consumers with electric light. The method of supply was direct current. It was later on in the year, in September 1882, that Edison opened the Pearl Street Power Station in New York City, and again it was a DC supply. It was for this reason that the generation was close to or on the consumer's premises, as Edison had no means of voltage conversion. The voltage chosen for any electrical system is a compromise. Increasing the voltage reduces the current and therefore reduces the required wire thickness. Unfortunately, it also increases the danger from direct contact and increases the required insulation thickness. Furthermore, some load types were difficult or impossible to make work with higher voltages. The overall effect was that Edison's system required power stations to be within a mile of the consumers. While this could work in city centers, it would be unable to economically supply suburbs with power. The mid to late 1880s saw the introduction of alternating current systems in Europe, and the U.S. AC power had an advantage in that transformers installed at power stations could be used to raise the voltage from the generators, and transformers at local substations could reduce voltage to supply loads. Increasing the voltage reduced the current in the transmission and distribution lines and hence the size of conductors and distribution losses. This made it more economical to distribute power over long distances. Generators could be located far from the loads. AC and DC competed for a while, during a period called the War of Currents. The DC system was able to claim slightly greater safety, but this difference was not great enough to overwhelm the enormous technical and economic advantages of alternating current, which eventually won out. The AC power system used today developed rapidly, backed by industrialists such as George Westinghouse with Mikhail Dobrovolsky, Galileo Ferraris, Sebastian Ziani de Ferranti, Lucien Gorlard, John Dixon Gibbs, Carl Wilhelm Siemens, William Stanley, Jr., Nikola Tesla, and others contributed to this field. While high-voltage direct current is increasingly being used to transmit large quantities of electricity over long distances or to connect adjacent, asynchronous power systems, the bulk of electricity generation, transmission, distribution and retailing takes place using alternating current. Market reform, such as transmission and distribution sectors from the contestable sectors of generation and retailing across the world. This has occurred prominently since the reform of the electricity supply industry in England and Wales in 1990. In some countries, wholesale electricity markets operate, with generators and retailers trading electricity in a similar manner to shares and currency. As deregulation continues further, utilities are driven to sell their assets as the energy market follows in line with the gas market in use of the futures and spot markets and other financial arrangements. Even globalization with foreign purchases are taking place. One such purchase was when UK's National Grid, the largest private electric utility in the world, bought New England's electric system for $3.2 billion. Domestically, local electric and gas firms have merged operations as they saw the advantages of joint affiliation, especially with the reduced cost of joint metering. Technological advances will take place in the competitive wholesale electric markets. Such examples already being utilized include fuel cells used in spaceflight, aeroderivative gas turbines used in jet aircraft, solar engineering, and photovoltaic systems, offshore wind farms, and the communication advances spawned by the digital world, particularly with microprocessing, which aids in monitoring and dispatching. Electricity is expected to see growing demand in the future. The information revolution is highly reliant on electric power. Other growth areas include emerging new electricity-exclusive technologies, developments in space conditioning, industrial processes, and transportation. Organization. The electric power industry is commonly split up into four processes. These are electricity generation, such as a power station, electric power transmission, electricity distribution, and electricity retailing. In many countries, electric power companies own the whole infrastructure from generating stations to transmission and distribution infrastructure. For this reason, electric power is viewed as a natural monopoly. The industry is generally heavily regulated, often with price controls, and is frequently government-owned and operated. The nature and state of market reform of the electricity market often determines whether electric companies are able to be involved in just some of these processes without having to own the entire infrastructure. All citizens choose which components of infrastructure to patronize. In countries where electricity provision is deregulated, end users of electricity may opt for more costly green electricity generation. All forms of electricity generation have positive and negative aspects. Technology will probably eventually declare the most preferred forms, but in a market economy, the options with less overall costs generally will be chosen above other sources. It is not clear yet which form can best meet the necessary energy demands or which process can best solve the demand for electricity. There are indications that renewable energy and distributed generation are becoming more viable in economic terms. A diverse mix of generation sources reduces the risks of electricity price spikes. World electricity industries. The organization of the electrical sector of a country or region varies depending on the economic system of the country. In some places, all electric power generation, transmission and distribution is provided by a government-controlled organization. Other regions have private or investor-owned utility companies, city and municipally-owned companies, cooperative companies owned by their own customers, or combinations. Generation, transmission and distribution may be offered by a single company, or different organizations may provide each of these portions of the system.